Hi, this is Dhana Abhiraj. I am introducing a new concept, logical agent. Logical agent is like you will build an agent. It will have logical agents, a virtual agents that you don't know what it does, what will it give response to the user. You don't know anything about. You don't care about logical agents. I have made a logic on how logical agents to interact with the original real agent. The user will only interact with the real agent. The real agent will observe the logical agent's responses. The logical agent observes the user also and give its observations back to real agent. The real agent then does the synthesis and gives the response to the user. What is the purpose on why I suggest logical agents? On how humans learn, we think is humans learn from others by seeing them and what they do or what actions they does. The same way, real agent learns from the logical agents. This is the main objective of the logical agents. Scale is all we need. We build agents, we need to adapt to different scenarios, different problems, and different multi-agent collaboration. This is an improved approach where we can scale as many agents as we want with the logical agents and reduce the error rate of current agent frameworks. The key features of logical agents are continuous training in inference. We don't do the LLM training. The agent itself learns, it observes the user input and learns and has its own perspective. Each logical agent has its own perspective. Then there is a combination of different perspectives, and each logical agent gives its own perspective to the real agent, and the real agent finally gives the his observation to the real user. We can just configure how many logical agents we need. Then we can run it. For now, we can set logical agents as 2, 3, 4, 5, 6, and 100 or 1000 we can configure. But the architecture needs to suit the logical agents. The current implementation supports effective utilization of minimal agents. In future, it will be improved to handle many logical agents effectively. Now we can configure as many agents and it will try to use. But the effective usage, we need to identify more. We'll do in the future. The logical agents has its own real-time user behavior observation and it learns from it and gives response of its observation to the real agent and the real agent does its observation. This makes human in loop built in the architecture. We'll first send the user message into the logical agents to observe. Then we will ask the original agent with the same user question or if some modification we can do. That the human in loop is involved. This logical agent has high accuracy in turbines, particularly Pascal parameter. These are the key features. This is like one agent you build, but it has multiple logical agents. These multiple logical agents are used to reduce the error rate of an agent. That's where the logical agents comes in. To reduce the error rate, we make the logical agents to observe the user and gives observation to the real agent, the one agent. The one agent will interact with the user and respond to the user. Our architecture. We will have logical agent with its own perspective, and we will have a group manager to manage all the logical agents that has been created. We can configure how many logical agents to be created and how many needs to be active at the inference, and the logic real agent and logic agents how it communicate. We define the communication using the autogen framework. Everything is developed using autogen, the logical agent and real agent. The perspective is specific to each logical agent to store its agent learnings. It also has the perspective. Based on the perspective, the group manager will subscribe logical agents to the group manager, whether it needs to be active or inactive. If it's active, the real agent messages will be sent, the user messages will be sent to logical agent, and the logical agent's observation will be sent to the real agent. If it's only have subscription to the topic, it's related to autogen, topic and subscription. If the perspective is unrelated to the user query, we will unsubscribe and we will only index the subscribed agents, and we will initiate the observation, the user message. Then we will have the real message that needs to be given to the user is generated by the real agent by using the observations of all the logical agents. Each logical agent can run in parallel. Example ability. How many hours in strawberry? This is one question that will fail in GPT-4o mini. I tried in GPT-4o mini, it fails. But in our framework, it says that's correct. The word strawberry has 3 hours. If you have any more other questions, tasks, it says correctly in most of the tries. I tried for 3 times, it passes 2 times, only one time it fails. I tried again, then it replied the correct manner. That's where the continuous learning in inference automatically happens. The roadmap for our logical agent is next. We have many applications, use cases to implement with the logical agents and improve its error rate, lower its error rate. We also need to implement different variety of perspectives like role model perspective to act in a different way and improve the indexing of logical agents. Only the correct indexing of logical agents will propel the error rate very down. We also need to improve the history and the learnings usage of the logical agent effectively in the future. We also planning to release a package that can be effectively used in projects, different projects. Now the current framework is also can be used in many projects. We haven't implemented in a way. When it comes to implementing those applications on how to use, I have some basic ideas. We can simulate a real human agent with more logical agents. That scale, the inference time is also very less. We can scale as many logical agents, and it effectively learns. We needs to only configure logical agents and what how many logical agents and how many active logical agents and logical agent books. It's like how many times it needs to observe logical agent books. We can also solve complex mathematical problem by giving this single problem by splitting the sentences and giving the sentence each and in each user conversation. Then finally, it solves complex mathematical problems. It's one type of approach to use the logical agent. And we can also use ARC problem to be solved by using logical agent. With since it supports continuous learning, but ARC is needs some visual based understanding. It has most reasoning capability logical agent has. It's like the Willow released by Google for quantum computing on chip. It's in the same way it is on physical qubit. To reduce the error rate, they map logical agents using their algorithm. The same way, the logical agents are designed in a way to reduce the error rate of the real agent. Thank you. Thank you for making me participate in the LLM Agent Hackathon. I learned new things on agents, and I have built a new framework, a new concept, a new architecture by extending the AutoGen framework. We will, in the future works, we will also try to make it independent and easy pluggable with different frameworks, agent frameworks. Thank you.